Right, in this video, we're going to talk about suggested homework problems from 9.8. We'll be talking about power series. Let's start with number 1, with representing a function. Explain how a Maclaurin polynomial and a power series centered at 0 for a function are different. So I think I mentioned this at the end of the last video, but a Maclaurin polynomial which is a special kind of Taylor polynomial that's centered at 0, approximates that's a key word there, approximates a function. Whereas a power series exactly represents a function. They're identical. The Maclaurin series has a finite number of terms and the power series has an infinite number of terms. So your Maclaurin polynomial or your Taylor polynomial closely approximate the function, especially at a point C, which is what they're centered at, and you'll be told what n is going to be for the polynomial, the nth degree of the polynomial, but the power series here is an infinite series, has infinitely many terms. It exactly represents the function. All right, let's go ahead and look at 3, which has to do with radius of convergence. So when we go through the ratio test here, we get to the point where we have the limit as n goes to infinity of the n plus 1th term of our series divided by the nth term of our series was equal to absolute value of x minus 2 over 5. And we know that that needs to be less than 1 for us to have convergence. So I'm going to multiply here. The series is centered at 2 and is going to have a radius, capital R, of 5, a radius of convergence. The interval of convergence, they didn't ask me for that yet, but would be x minus 2 is between -5 and 5, and then I'd add 2 to everything to say that my interval of convergence is between -3 and 7, and then I'd have to test the endpoints in the function to see if I would have absolute or conditional convergence at the endpoints. So we'll be doing that here in just a little bit. Let's look at number 7, where we talk about where the center C is for this series. N equals 0 to infinity, x minus 2 to the n over n cubed. So the center is where this factor that's raised to the n power would be 0, because if I add an infinite amount of zeros, that's pretty trivial that that converges to 0. So C is equal to 2. So we always converge at the center, but we may have an interval of convergence beyond that that's open, half open, closed. It may be infinite on one side or both sides. We'll have to see what our interval of convergence looks like here going forward. Let's look at number 11, where I think we're going to talk about that. We're going to talk about radius of convergence first. So 11 takes what we were just doing in problem number 3, and we actually do the ratio test here. So this is going to be the limit as n goes to infinity of the n plus 1th term is 4x to the n plus 1 over n plus 1 to the second. And I'm going to multiply by the reciprocal of this nth term. And that absolute value needs to be less than 1. So I'm going to take the limit as n goes to infinity. I'll keep my n parts together here. N squared over n squared plus 2n plus 1. Then I'll have this other part that is x's. So n plus 1 minus n is first power. And then this limit here is going to 1 times 4 is going to be 4 times the absolute value of x is less than 1. So the absolute value of x is less than 1/4. So my radius of convergence is 1/4. All right. Let's look at number 15 here. And I'm supposed to find the interval of convergence now. So that requires a little bit more work. And in this one, I could use the geometric series test to help me. I don't need to use the ratio test because this one is geometric. So I know my r, the absolute value of my r, has to be less than 1. So the absolute value of x has to be less than 4. So x has to be between -4 and 4. If I look at -4 divided by 1 is -1 to the n. So that doesn't pass the nth term test because my nth term is either going to be -1 or 1. Same thing with 1 to the n is going to be a whole bunch of 1s. That doesn't pass the nth term test. So it doesn't converge at either endpoint. I have the open interval from -4 to 4 for my interval of convergence. Your teacher may want it written with inequalities like this or like this. Check to see in what way they want you to express your answer for your interval of convergence. Now let's look at number 19. Summation n equals 0 to infinity, x to the 5n over n factorial. That n factorial keeps me from using the geometric series test. So I'm going to instead use my ratio test, x to the 5 times n plus 1 over n plus 1 factorial times the reciprocal here is n factorial over x to the 5n. These are in absolute value bars, less than 1. Limit as n goes to infinity of this. Keep my n parts together is n factorial over n plus 1 factorial is 1 over n plus 1. And then this is x to the 5n plus 5. It's going to be x to the 5th when I subtract 5n there, less than 1. Now as n goes to infinity here, 1 over n plus 1 is going to be 0. 0 times anything is 0 will always be less than 1. So this is going to have an interval of convergence of -infinity to infinity, or all real numbers. Let's look at number 25. Summation n equals 1 to infinity, -1 to the n plus 1, x minus 4 to the n. over n times 9 to the n in the denominator. So forget about the sign change of the absolute value, is going to get rid of that. I have x minus 4 to the n plus 1 over n plus 1 times 9 to the n plus 1 times the reciprocal n, 9 to the n over x minus 4 raised to the n. Absolute value bar less than 1. Up front, I need limit as n goes to infinity. So limit as n goes to infinity of, then this is going to be 9 down here. And I have an x minus 4 up here. And I have n over n plus 1. And I have a 1/9 here. And I have absolute value of x minus 4. So I have less than 1. That this limit here is 1. Absolute value of x minus 4 is less than 9. When I multiply both sides by 9 to get rid of the 1/9, means x minus 4 is between -9 and 9. Add 4 to everything. That gives me -5 less than x less than 13. I want to check this starting with the negative side here. This is going to be -9 and plus 1 times a -1 to the n times 9 to the n over n times 9 to the n will be summation n equals 1 to infinity. So that's a negative n equals 1 to infinity of 1 over n, which is a divergent p-series. That -1 constant multiplier doesn't make it alternating because it's no longer to the n. There was always an odd number of negative signs, so it was always negative. Let's check the right-hand side here. If I put in 13, this is -1 to the n plus 1 times 9 to the n over n times 9 to the n, summation n equals 1 to infinity. The 9 to the n's cancel. This is an alternating series with the limit as n goes to infinity of 1 over n is 0, and 1 over n plus 1 is always less than 1 over n. So it's always decreasing. So it is conditionally convergent. The fact that it's an alternating series on the right-hand side. So my interval of convergence is -5, open on that side to 13, closed on that side. And my R, if I need it here, was 9 because I solved for the absolute value there and it was 9. Let's look at number 33. Summation of n equals 0 to infinity of x to the 3n plus 1 over 3n plus 1 factorial. So I want limit as n goes to infinity of x to the 3n plus 3 plus 1 is 3n plus 4 over 3n plus 4 factorial times 3n plus 1 factorial over x to the 3n plus 1 less than 1. Limit as n goes to infinity of 1 over 3n plus 4, 3n plus 3, 3n plus 2, and then I have x to the third less than 1. This is going to go to 0. So my interval is -infinity to infinity. My radius is also infinity. Let's look at 41. Summation n equals 0 to infinity of x over k to the n. It's a geometric series, so that means absolute value of x over k has to be less than 1. Absolute value of x has to be less than over k. Assuming k is positive, I think they say, right? Yeah, k is a positive integer, so that's over k less than 1. Absolute value of k, or absolute value of x is less than k. X is between negative k and k. And if I would test this, negative 1 to the n doesn't converge. 1 to the n doesn't converge, so my interval of convergence is negative k to k. That's it for this video. We'll come back next time and talk about suggested homework from 8.9. Sorry, 9.9, which is representation of functions by power series. So we'll look at 9.9 next time. See you for the next video.